In the last presentation, we finished the introductory section on objects. In this presentation, I'll go over the solutions to tutorial number 8. This tutorial covers a class called MyStringOne. This class is very similar to a class that is studied in lab number 4, and it allows you to allocate character arrays on the heap to make handling strings much more easy. So I'll cover all but the last question for tutorial number 8, and it'll give us practice with classes, dynamic memory, and drawing activation records, or memory diagrams. It'll also introduce some problems that come up with member-wise copies. And recall that for member-wise copies, if you have an object A and assign it to an object B, all of the members of A will simply be copies of the members of B. Let's begin by looking at the interface, or the prototypes, for the MyStringOne class. All of these would be inside of a header file that's called MyStringOne.h. This code is given in the tutorial, so I will just cover the main points. First, notice there are two constructors, a default constructor that has no arguments, and another constructor which has a pointer to a character for C strings. Next, the destructor is defined. You can tell it's a destructor because of the tilde. And this class uses heap memory, so the destructor is a good place for deallocating heap memory. Next is two get accessor functions, one returning the length of the string, and the other one, getChar, returns the character at a specific position. Next, the cstr function returns the C string, or a pointer to a character. Also notice that it's a pointer to a character that is constant. That prevents a user from changing the string from outside of the class. Next is setChar, which can change the character at a specific position in the object's string. setChar checks that the position is valid, and also that the character being inserted is not a \0, which would affect the length of the string. And finally, there's append and truncate, which are used to expand or contract the string stored by a MyStringOne object. And at the end of the class declaration, we have the private members, length m, and storage m. And these are in the private section following the information hiding principle for designing classes. Now that we have the interface to the class defined in the header file, let's see the definition of those functions inside of MyStringOne.cpp. In this first slide, we see the details of both constructors and the destructor. If we focus on the default constructor, the one with no arguments, we'll see in the member initialization list that length m is initialized to 0 and storage m is initialized to a character on the heap, with the statement new char and then square brackets 1, which allocates an array of length 1. I should point out that the m at the end of the member variables stands for member, so you can separate which variables are local and which ones belong to a class. That can make your code more readable for someone who's not familiar with it. The second constructor is declared similarly, except that it copies a string which is passed in as an argument. And lastly, the destructor uses the array version of delete to remove the storage that's allocated on the heap for the storage m character array. The remaining functions that are defined are simple get and set functions. That is usually the case that accessor functions or get set functions have a simple definition. Now that we've reviewed the class MyStringOne, you're prepared to attempt to answer the questions in tutorial number 8. So now, at this point, try to predict the output at point 1 inside of the main function. The output at point 1 will simply say constructor is called, constructor is called. This is because when you declare the MyStringOne S1 and S2, they're both calling the second version of the constructor, not the default constructor. This is because they do have an argument passed in when they're declared. Also note that MyStringOne S3 is a pointer and it's not actually declaring an object. Because of that, there's no output for the declaration of S3. And now please try to draw the memory diagram at point 2, which is inside of the setChar function. Here is the memory diagram at point 2. There are a few things to note at the start. First, the class MyStringOne allocates memory on the heap. Each object, for example S1 and S2, have their storage M pointers pointing onto the heap. Also note that S3 points to an object which is itself on the heap, and its storage M pointer again points to a string on the heap. Because S3 is the one that invokes the function setChar, the this pointer inside of setChar is pointing to the object on the heap, which S3 points to. The result of the setChar function is that the object on the heap points to a string that says RDD instead of RED. And now please attempt to predict the output at point 3 in the program. At point 3, all of the output will be due to constructor and destructor calls. In addition to the two constructor calls for S1 and S2, which we saw at point 1, when the operator new creates a MyStringOne object on the heap, that also calls the constructor, and we see our third constructor is called because of the new statement for the assignment of S3. The next line, calling setChar on S3 and getChar on S2, does not produce any output. The following line, which assigns S4 a pointer to a MyStringOne object, creates an array of MyStringOne with 2 elements. And because arrays always use the default constructor, we'll see 2 statements saying that default constructor is called. The last statement uses something that we haven't seen before. We declare an object called S5 and we say it's equal to S1. This is actually calling a special constructor called the copy constructor. We will see later in the course more details about the copy constructor, but for now all you need to know is that when you declare an object equal to another object, it uses the copy constructor, and the default copy constructor simply copies all of the members from S1 into the members of S5. In this case, the length M member of both S1 and S5 will be 4, and both of their storage M pointers will be pointing to the same array on the heap. Now because we didn't declare a copy constructor explicitly, the compiler uses an automatically generated copy constructor. That means that there's no output for the construction of S5. One more output statement will be seen, and this is because S5, which is a local variable, is enclosed in braces. After we leave the braces to get to point 3, S5 goes out of scope, and when objects go out of scope, their destructor gets automatically called. So we see one call to destructor is called for S5 when it goes out of scope. Since the objects created with new live on the heap, they will live past the end of the braces, and will only be destructed when the delete operator is called on them explicitly, or when the program terminates. Now you can try to draw the memory diagram at point 4 in the program. And to help you with that, the statement before point 4, S2 equals S1, does a member-wise copy of the elements in S1 to the elements in S2. Here at point 4, there are several things to note. If we look at the top of the heap, we'll see 2 default constructed members of an array of MyStringOne. That's the array that S4 was pointing to in the previous question. However, since delete was not called on those elements, they stay on the heap until the end of the program. This is known as a memory leak, because the memory can't be recovered and will stay until the end of the program. There is also another memory leak at this point. Can you spot it? In the statement S2 equals S1, a member-wise copy was performed from S1 to S2. So the string that was on the heap for S2 before, that says red, is now no longer pointed to, and that memory is leaked and can't be removed until the program terminates. The final thing to note was that when S5 was constructed. It was constructed with a member-wise copy of S1. So that meant that S5 was pointing to the same string that S1 pointed to. However, when S5 went out of scope, that string was deallocated in the destructor with a call to delete. So now S1 and S2 both point to a garbage string which has been deallocated on the heap. We indicate that with question marks for what they point to. Question 5 for the tutorial asks to predict what the output is when the program terminates. I have copied the output onto this slide. It might not be what you would have expected, but if you remember that S1 and S2 both pointed to the same string which had already been deleted. Because S1 and S2 both point to the same memory which is deleted, when you call delete a second time, it produces the following error which says a double free or corruption has occurred. This problem was a result of a shallow copy or a member-wise copy. Had the arrays themselves actually been copied instead of simply pointing to an existing string, this error would not have occurred. We'll learn more about how to avoid this by creating our own copy constructor and our own assignment operator later in the course. In this presentation, we saw the solutions to tutorial number 8 in the workbook. Tutorial number 8 was a good review of some of the concepts we've learned for dealing with objects in C++, and it also introduced the idea of memory leaks. A memory leak is said to have occurred if something exists on the heap but there's no pointer to it. You should avoid creating memory leaks when you write programs. The memory leaks in this program existed because of a member-wise copy, or a shallow copy, which is where the members of one object get assigned directly to the members of another object. This was a problem because we had two objects pointing to the same thing on the heap. In one case, this caused the program to crash with a double free error message. In that case, one object was destructed, but a second object survived and pointed to the deallocated memory. So when it was destructed, it caused the program to crash because it tried to delete already deleted memory.